We'll be looking at some useful identities that we'll use in solving these questions. One of the identities that we'll be seeing more will be alpha square plus what? Plus beta square. Now, how can we get the answer to this? We know alpha square plus beta square can be seen in alpha plus beta all squared, right? So, if I expand this, I'm going to be having alpha plus beta into alpha plus beta. So, and this will give us alpha times alpha. We have alpha square. We have plus alpha beta plus alpha beta plus beta square. That is alpha times alpha, alpha square. Alpha times beta, alpha beta. Beta times alpha, alpha beta. Beta times beta will give you beta square. Now, if I collect like terms, I'll be having my alpha square plus 2 alpha beta plus what? Beta square. So this is my alpha plus beta all square. Now what I really need is my alpha square plus beta square. So if I rearrange it properly, I'll be having alpha plus beta all square is equals to alpha square plus beta square plus what? 2 alpha beta. I've rearranged it. Now I need this 2 to remain in the left hand side, remain here. So I'm taking this to the other side. So this will give me alpha plus beta all square minus what? 2 alpha beta equals to alpha square plus what? Beta square. So when this guy is coming here, it becomes a negative. So therefore, my alpha square plus beta square will be equals to alpha plus beta all square minus what? 2 alpha beta. That is another relationship here that we have to know. Another useful identities. Now similarly, that is 1, this is 2. The next one we have alpha cube plus what? Beta cube. We need to know the relationship. Now we know that we can see alpha cube plus beta cube in alpha plus beta all cube, right? So this will give me alpha plus beta. If you take them into 3 equal parts, this will give me alpha plus beta, and this will also give me alpha plus beta because of the power. So into 3, right? So now we know that when we expand these 2, which we expanded here, right, we're having this. So I can easily put and say my alpha square plus 2 alpha beta plus beta square. So when you expand this is what you're having. So close to what? My alpha beta. So I expanded these 2, right? So now let's move further. So if you say alpha times beta square to give you alpha times alpha square give you alpha cube. Alpha times alpha here will give you 2 alpha square beta. Alpha times beta square will give you alpha beta square, right? Now beta times alpha square will give you plus alpha square beta. Then beta times the beta here will give you plus 2 alpha beta square. Then beta times beta will give you plus what? 2 plus what? Beta cube. Beta times beta square will give beta cube. Now if you collect like terms, and now I have my alpha cube. This is 2 alpha square beta, and this is 1 alpha square beta to give you 3 alpha square beta. and this is alpha beta square. 1 alpha beta square plus 2 alpha beta square give you plus 3 alpha beta square. Then we're left with what? Plus beta cube, right? So this is what we're having when you expand this. Now when you do this, we know my alpha plus beta all cube is giving me this. So if I rearrange it, my alpha plus beta all cube will be giving me alpha cube plus beta cube plus 3 alpha squared beta plus 3 alpha beta square. Is that taken? So I rearrange them. Now from here, I want these 2 alpha cube plus beta cube to remain here while the rest to go to the other side. So we'll be having my alpha plus beta all cube minus 3 alpha squared beta is coming here, become minus 3 alpha beta square is equals to what? Alpha cube plus what? Beta cube. Now as it is this way, I'm having alpha square beta. I need to factorize to make them be in the form of alpha times beta and alpha plus beta. So what I do, I'm going to factorize this here. So look at what I want to do. Now I have alpha plus beta all cube, right? I have minus. I'm going to put a bracket here. Is that the king? Now, and I'll put another bracket here this way. I'm factorizing this guy here, these 2 here. Now, I'm having 3 here and I'm having 3 here. So I'll bring 3 outside. Right? Then I'm having alpha here. I'm having alpha here. I'll also bring alpha outside. Do you get logic? I'm having beta here. I'm having beta here. I'll bring what? The beta outside. So what is remaining in? If you remove 3 here, 3 is gone. If you remove alpha, it remains 1 alpha here. Right? If you remove beta, so we're having this plus what? Beta. So this is what we're having. Right? Is equals to what? Alpha cube plus what? Beta cube. So therefore, my alpha cube plus beta cube is equals to what? Alpha plus beta all cube minus what? 3 alpha beta into brackets alpha plus beta. So this is what we're having. So this is another relationship here. So that is number. So the next one is alpha cube minus what? Beta cube. This is another relation. So we're looking for this. So what you should ask yourself is, I can see alpha cube minus beta cube in alpha minus beta all cube, right? So if I try to expand this, I'll be having alpha minus beta bracket alpha minus beta bracket alpha minus beta in 3 places. Now if I expand, I'll take 2 at a time. If I take these 2, alpha times alpha, we have alpha squared. Alpha times minus beta will give you minus alpha beta. Minus beta times alpha will give you minus alpha beta. Minus beta times minus beta will give you plus beta squared, because minus times minus is what? Is plus. Right? So we're having alpha minus what? Beta here. So if you collect like terms, alpha squared minus 1 alpha beta minus 1 alpha beta will give you minus 2 alpha beta. Then we have plus what? Beta squared. So into brackets my alpha minus beta. Now if you expand this together, alpha times alpha squared will give you alpha cube. Alpha times the alpha here will give you minus 2 alpha squared beta, because alpha times alpha is alpha squared. So alpha times beta will give you plus alpha beta square. Now I'm going to beta now. Minus beta times alpha square will give you minus alpha square beta. Minus beta times beta here, but minus times minus is plus. Beta times beta is beta square, so we're having 2 alpha beta square. So minus beta times plus beta will give you minus what? Beta cube. So from here, we'll collect our like terms. This will give me alpha cube minus 2 alpha square beta minus 1 alpha square beta will give you minus 3 alpha square beta. So we have 1 alpha beta square plus 2 alpha beta will give you plus 3 alpha beta square. So minus what? Beta cube. So this is my alpha minus beta all cube. So what I want to stay in this side is alpha cube minus what? Beta cube. So I'll say that my alpha minus beta all cube is equals to alpha cube minus beta cube minus 3 alpha square beta plus 3 alpha beta square. Right? So if they are coming to this side, this will become positive. So have alpha minus beta all cube plus 3 alpha square beta. Right? If this is coming, it become minus 3 alpha beta square is equals to alpha cube minus what? Beta cube. Now we need to put this in the form of alpha beta. So we are going to factorize again. So by factorizing, what I did the other time, your alpha minus beta all cube will give us it's going to give us, let's see how it goes. So it can give us, if you factorize this, so if you factorize this, let me take you down the memory lane. Now look at this. And this here I'm having my plus 3 alpha square beta minus 3 alpha beta square. So if you bring the plus out, if you bring the plus out, you'll be having minus 3 alpha beta into bracket alpha plus beta, right, equals to alpha cube minus beta cube, right? Therefore, my alpha cube minus beta cube will be equals to alpha minus beta all cube minus 3 alpha beta into bracket alpha plus beta. So that's what to give us. This is for this. And this can be still written as, can still write that as saying, can still write this as saying alpha cube plus beta cube is equals to alpha minus beta into bracket alpha plus beta all square minus alpha beta, right? So you can still write it like this. Thank you very much.